Hello everyone, welcome to lecture 3 of programming with C++. So I go by the name for Abapi. Today we are going to learn one of the features of C++ that will help you become a better programmer. So let's start by looking at what we'll cover today. By the end of this lecture, you'll understand pointers, okay, and then arrays, and then the combination of pointers and arrays, and then references. So what are pointers? Let's start with let's start with pointers. Okay, so imagine you have a piece of paper with someone's home address written on it. The paper doesn't contain the actual house, but it tells you exactly where to find it. So a pointer works the same way. It's a variable that stores the address of another variable in your computer's memory. So pointers can be used with any data type: integers, characters, floating points, and then you can name them. Even incredibly versatile and powerful. Okay, so creating a pointer. Creating a pointer is similar to creating any other variable, but we use a special symbol, okay, and that's the asterisk. The basic structure is your data type, and then you bring your asterisk, and then your name, then you terminate it. So here, let's open our code blocks for the practical. So our code block is now ready. So the basic structure for creating pointers um, is the data type. Then you bring your asterisk, and then the name, and then you will terminate. So for example, if you want to create a pointer that can point to an integer, then you bring um, your data type, asterisk, and then your name, and then you terminate it like this. So moving on to assigning address to pointers. Now that we know um, what what pointer is, now that we have a pointer, okay, we need to give it an address to point to. We use the address of operator, which is the ampersand symbol. Okay, we all know the ampersand symbol. So let's say we have an integer variable. So int, and then you bring your name, identifier, then you bring your assignment operator, then you bring your value, then you terminate it. Just like this. Okay. Yeah. So moving on to the
You can say.
Dereferencing a pointer. So it's the process of accessing the actual value that a pointer points to. Think of it like following the address on that piece of paper to the actual house. Okay, you are going to visit, or you are going to, okay, for maybe delivery or something. We use the asterisk symbol again. Okay, so um this means go to the address and get the value stored there. Here is how it works. First, you bring your data type. So we are using int, and then you bring your asterisk. You bring your name, and then you will bring your assignment operator.
Yeah.
Are you up?
Yeah. You can say. Yes, it's right.
And then let's see out the name.
Right.
Moving on to modifying a pointer address. One of the features of pointers is that you can change what they point to. As long as the new variable is of the same type, you can reassign the pointer. So here's an example.
So, yeah.
So let us see what it is. Moving on to the data sizes of pointers. So Here's something interesting. Okay, so all pointers are they are of the same size, reg- regardless of what type of data they point to.
Okay.
What data they point to. This is because they all store memory addresses, and all addresses are of the same size. So the size depends on your computer's architecture. So on a 64-bit system, um, the data size is 8 bytes, and on a 32-bit system, the data size is 4 bytes. So going on to special types of pointers. Now let's discuss some special types of pointers you should be aware of. So one, we have wild pointers. They are pointers that haven't been initialized. They contain random memory addresses that may or may not be valid. Okay, so this is dangerous because you don't know where they are pointing. And then we have null pointers. Null pointers are pointers that um, explicitly point to nothing. They are initialized to null to indicate they don't point to any valid memory location. Okay, and then we have void pointers. Void pointers can point to any data type. They are generic pointers that do not have specific type associated with them. Okay. So and then dangling pointers to are pointers that point to memory that has been freed or is no longer valid. This happens when the variable they were pointing to goes out of scope or is deleted. So that's all for pointers, and then moving on to references. Moving on to references. A reference is like giving a nickname to an existing variable. When you use the reference, you are actually working with the original variable directly. Think of it this way. If your name is John and your friend call you Johnny, both names refers to the same person. Okay. So my name is Faustina, but my friends calls me Sven or Tuna. Yeah. So it's the same me. Okay. So reference are very useful because they allow you to work with the original data without making copies, which can be more efficient. So comparing um, reference versus pointers. What's the difference between reference and pointers? The key difference is in how they are used. Pointers allow us to pass large amounts of data around efficiently. Okay, so instead of copying all the data, we just pass the address where the data is located. References provide more direct way to work with the original data. They are like having a direct connection to the original variable, while pointers are like having the address where you can find the variable. And then creating references. Creating reference is straightforward. We use the ampersand symbol, but in a different context than with pointers. So let's look at the syntax, some of the syn- Moving on to arrays. Now let's move on to arrays. Okay, so an array is a collection of multiple objects of the same type stored one after another in memory. Okay, so it's like a row of lockers in a school hallway. Each locker can hold one item, but they are all the same size and they are numbered sequentially. Individual items is an array. Individual item in an array are called array elements. Okay, and then we can access each element using its position number called an index or subscript. And then array indexing. Array indexing is how we access individual elements. The index specifies the position of elements in the array, and then it starts from 0, not 1. Okay, so we use square brackets to access elements. So moving on to initializing array. When we create an array, we often want to give it initial values. We can do this by providing a list of values in curly braces. And then array initialization. Sorry, so moving on to multidimensional. So this is the declaration of arrays. Okay, so moving on to multidimensional arrays. So far as we've looked at one-dimensional arrays, like a single row of lockers, but we can also create multi-dimensional arrays, which are like having multi-rows and columns. So declaring 2D arrays. Two-dimensional arrays can be visualized as a table or matrix. Each element is accessed using two indices, one for the row and one for the column. This creates a 4 by 4 grid, like a chessboard section. You can think of it as having 4 rows and 4 columns, similar to how you might organize data in an Excel spreadsheet. Alright, so and then moving on to declaring 3D arrays. How to declare 2D and 3D arrays. Three-dimensional arrays add another dimension. They are like having multiple layers of 2D arrays stacked on top of each other. Okay, so this creates an array with 4 rows, 4 columns, three layers deep. Okay. And then you can also think of it like having 3 sheets of paper, each with a 4 by 4 grid down on it. Okay, so and also stacked on top of each other. Okay, so here And here is the 3D arrays, and then here is the 2D arrays. Okay, so here is our lecture. We continue our next lecture at that time. Bye bye.